Good morning. Today we are going to concentrate on the content part which was taught on the first day of our winter classes. So we were doing questions from our manual. We're doing the question on rational function. We're doing a question on rational function. We're doing a question on rational function, which is also known as the hyperbola. It's the hyperbola there. So we are given that fx is equal to 4 over x minus 1 plus 2. Then the first question was saying write down the equation of the asymptotes of f. So to get the equation of the asymptote, first part, to get the first equation, we have to equate the denominator to 0. So it means we are going to have x minus 1 equal to 0. This equation reduces to x equal to 1, and this is x equal to a constant. This is a vertical asymptote. It's a vertical line. So the x equal to a constant here is going to be our vertical asymptote. This one is our vertical asymptote. Then the second one, you have to take, to get the second equation of asymptote, it means you have to treat this whole fractional part as a 0, meaning to say it's going to be, when you treat the whole entire fractional part as a 0, this is going to give us y equal to, take note, this fx is the one which we take as our y. So y is equal to 0 for that fractional part plus 2. Y is equal to 2. So this becomes our horizontal asymptote. This becomes of our horizontal asymptote. So we already have, this is equation 1, this is equation 2. We have the two equations of our asymptote. The second question was saying calculate the x-intercept of f. So this was 4.2.1. Then we go to the second one. It wanted the, so it's 4.2.2. So it's gonna be 4.2.2. The question wants you to get the x-intercept. But to get the x-intercept, we have to know that we substitute y equal to 0. And if you check, our function is given as fx equal to 4 . That's our function is given as 4 divided by x minus 1 plus 2. So y, this part here, is the one which is representing our y. So we let that to be 0. So it means 0 will be equal to 4 over x minus 1 plus 2. Transposing this to the other side, it becomes negative. So we are now going to have minus 2 being equal to 4 over x minus 1. But you have to take note that this one is as good as over 1. So to solve there, we have to cross multiply this and that. We are going to have minus 2 x minus 1 being equal to this and that, which gives us a 4. So minus 2x plus 2 must be equal to a 4. Then a negative 2x, we transpose the 2 to that other side. So it means when it goes there, it becomes negative 4 minus 2, we get a 2. Then we divide both sides by a negative 2, a negative 2. So conclusively, our x is equal to a negative 1. Therefore, we can just say that our x-intercept is given by the coordinates negative 1, 0. I recommend that you write the answer in coordinate form, even though in this case they did not specify, leave the answer in coordinate form. Then we go to the next question, which is 4.2.3. They are saying sketch and label. So we need to sketch the graph. So for us to sketch the graph, we need to sketch the graph. That is 4.2.3. You are required to sketch the graph. So to sketch the graph, it therefore means that we have to first, for us to sketch the graph, we are going to need the asymptotes. We are going to need the asymptotes. And if you check our asymptotes, we have them already. Here are the equations of our asymptotes. We are having x equal to 1 as our asymptotes, x equal to a positive 1. We also have y equal to a positive 2. Then, what else do we need to sketch the graph? We will need the x-intercept. So, if we check our x-intercept, what are we having? We need the x-intercept, and our x-intercepts, the coordinates, we found them to be a negative 1, 0. Then we also need the y-intercept. So in this case, we need also the y-intercept. And we know the y-intercept, we have to substitute x equal to 0. So we take our equation. So our equation was saying fx equal to 4 over x minus 1 plus 2. If we substitute where there is x with a 0, so it means this part is representing our y. So it means our y will be equal to 4 over 0 minus 1 plus 2. Eventually, our y is equal to negative 2. After simplifying this, trust your calculator. So it means the coordinates of the y-intercept can be written as 0, negative 2. Now we have these sets. We now need to sketch our graph. So to sketch our graph, we are going to show our y-axis, which is our vertical axis there. Then we will need our x-axis. There it is. That's our x-axis there. Label it properly. Here is the origin. Then we mark our asymptotes. Y is equal to 2. So the equation y is equal to 2 is a horizontal line. So it means it's going to be, we use a broken line. So that's our equation. Y equal to 2. We label that. Then we need x equal to 1. It's a vertical line. Here it is. So this is our x equal to 1. Then to sketch, because we have 4 which is positive there, because the standard form of a rational function will be fx equal to A over x minus P plus Q. So if this A is positive, it means the arms of our graph must lie in the first and third quadrant of our asymptotes. So it means we are going to have our first arm here. Then we have our second arm here. If you check, we realized that we have our intercepts as -1 and -2. So our graph is the x-intercept, we found it to be -1. The y-intercept, we found it to be -2. Then don't forget to label the graph. It's F here. It's F. That's our graph. It's F. If we are to take note, the question place a label or asymptotes. There we have our asymptotes. It also it was also saying indicate the intercepts. We show all the intercepts with the x's. So sometimes they want you to show with any other point. So it means if we wanted any other point on the graph, we are going to choose any x value just after the asymptote here or before the asymptote here, but take note, any other point we must not consider the intercepts. So it therefore means that we were going to choose any value. So it was possible that we can just say when x is equal to 5, let's substitute. When x is equal to 5, what was going to happen? So it means in our function, it was going to mean that our y was gonna be equal to 4 over 5 minus 1 plus 2. Then if we simplify that, it therefore means the y was gonna be equal to, here it's 1 plus 2, 3. So any other point that we have here, we can use 5, 3. So here 5 is somewhere, because here we realized that here we are at 1. So 5 can be somewhere here. So we can mark this point and call it our 5, 3. So we are done there. We go to the next question. It's now saying use the graph to determine the values of. So we are going to use the graph 4.4. So it's 4.2.4. Let us go. It's 4.2.4. There. So it's saying use the graph to determine the values of x for which 4 over x minus 1 is greater than or equal to -2. But since the question is specifically saying use the graph, it means we must go back to our graph. So if we are to check from the information that we are here given here, we can transpose that to that side. So when we transpose that, we are going to have 4 over x minus 1, then it becomes plus 2 is greater than 0. But if you check 4x over x minus 1 plus 2 is our fx, which we were given. So in other words, we are having a question which is saying fx is greater than 0. So if we are saying fx, this is our function here. So when we are saying our function is greater than 0, what is it that we are meaning? It means we want the part of that graph, which part of f, which is above the x-axis. Part of f which is above the x-axis, part of x which is above the x-axis. That's the meaning of fx greater than 0. So if we go to our graph, we would realize that this part of the graph is above the x-axis, going there. Then, if we are to check again, if we come this side, it's now below the x-axis. In other words, we are saying this is our x-axis. Let's put this is our x-axis. So, in other words, we are saying we want part which is above the x-axis, part which is above this red line that I put, part of the graph which is above this red line. So we would realize that is this part which I marked in green, which is here, this part here. Then we would realize again that is also this part here. It's also this part there, it's above the red line. And you have to take note on our question, it's accommodating or equal to here. So which part is above? We would realize that when x, our solution for that, we are realizing that when x is less than -1, but if you check at -1, it's equal to 0. So we are going to accommodate or equal to, then or the other part which is we shaded green is this part after the vertical asymptote, also when x is greater than 1. But here, if you check the other side, we are not going to accommodate or equal to at 1. Why? Because at 1, we are having an asymptote, meaning to say our graph can never be at 1. So this part becomes our solution. So our solution is given by x is less than or equal to -1, or x is greater than 1. Then let's go to the last part of the question. The last part of the question was saying determine, let's put that one. That was question 4.2, 4.2.5. It was saying determine the equation of fx, the equation of the axis of symmetry of x minus 2 that has a negative gradient. So if we are to check, number 1, it was possible to just check f x minus 2. What does this give us? It simply means from the original function that we were having, we are going to, wherever there is x, we were going to substitute x minus 2. So it means this was going to give us a 4. So fx minus 2 was going to give us a 4 over, where there is x here, we are going to give an x minus 2 as illustrated there. So it was going to be x minus 2 minus x minus 2. Then we are having minus 1, because where there was x, that's where we substituted x minus 2 there. Then we substituted minus 1 as from the original fx. Then we put our plus 2 outside there. So if we simplify this one, it means the fx minus 2 there was gonna be equal to y, was gonna be equal to 4 over x minus 2 minus 1, which gives us minus 3. Then we have plus 2. But the question, it wants the equation of the axis of symmetry that is having negative gradient. So to get the equation of the axis of symmetry, we are going to read this equation this way. Here we only take the denominator, then come there, and the part which is on the denominator is going to be multiplied by negative, to get the equation of axis of symmetry having negative gradient. And take note, this part here, which is on the left hand side, will be denoted, will be replaced by y. So the equation having the axis of symmetry, it therefore means that it's going to be given by, it means the axis of symmetry is therefore going to be given by y equal to negative x minus 3 plus 2. So this is going to give us negative x positive 3 positive 2. So the equation is given by y is equal to negative x positive 5. This becomes our equation here. Oh, it was possible that we were just going, it was possible that we were just going to take our fx as it is. So our fx is equal to 4 over x minus 1 plus 2. Then, first we have to get the equation of the axis of symmetry having negative gradient of this. So to get the equation of the axis of symmetry here, it means we're going to read it this way. But to get the one having negative gradient, we're going to put a negative there. So it means this part here, we are now going to take it as our y. So we're going to have y equal to minus open bracket x minus 1 plus 2. So eventually it means this was going to be y equal to minus x plus 2, plus 1 plus 2, which was going to give us y is equal to minus x plus 3. This is the equation of the axis of symmetry having negative gradient from the original equation. But this, now the question was wanting you to give axis of symmetry having negative gradient of what? Of f x minus 2. So using transformations, you're supposed to know that fx minus 2, this part, is representing a graph that has been shifted to the right by 2 units. So if the graph has been shifted, f has been shifted to the right by 2 units, it simply means that even the axis of symmetry, whatever, even the asymptotes have been shifted to the right by 2 units. So to now get the equation of the axis of symmetry required in this particular question, it simply means from the axis of symmetry having fx, we're going to substitute x minus 2 wherever there is x. So it means from there, we are now going to get our equation as y equal to minus, where there is x there, you substitute x minus 2 plus 3. So it's going to give what? Y equal to negative x positive 2 positive 3. So y is equal to negative x positive 5. This becomes our answer. Thank you.